Hey coders, welcome back. So today we are again going to take the challenge of solving online assessment based practice from the Leetcode. So if you don't know, there is a page in Leetcode, leetcode.com/assessment. So you can choose either online assessment, phone interview, or on-site interview, right? So it basically gives you two, three questions from the real companies that has been asked, and you try to simulate it. Basically, try to simulate a real world scenario kind of thing, right? So you can simulate interview. You can express your thoughts, how you are solving the question, and yeah, maybe try to solve all those questions. So that's the idea. So this is our day 10, I think, of this my video series of solving a mock assessment. So in my last video, I took this online assessment one. So in today's video, let's try to go one level up with on-site interview, and it might have like three or four questions. Yeah, we try to solve all of them, and let's see how it goes. Okay, so let's start. Let's start with on-site one today. So there might be three questions or four questions, right? And you have 2 hours to complete. You cannot pause the timer and all. So yeah, let's see. So we have three questions. Okay, let me remove this comment. Okay, so the very first question says, given the head of a single linked list, return true if it is a palindrome or false otherwise. So this is the question, right? The number of nodes in the first list is a range from this. So it's like 10 to the power 5 nodes might be there. So we have to solve obviously in linear based algorithm. And now it says a follow up. Could you solve it in linear time with constant space? So this is good. So let's first try to understand it without with taking extra space, and maybe later we will try to optimize this according to the question, right? So for linked list based problem, I would highly recommend you know how to traverse the linked list. I think that is the most fundamental thing in a linked list. So you should know how you're gonna traverse a linked list because there is no direct access in a linked list, right? You have to start from the head and work all around till the tail, right? And express the elements. So it says like for 1, 2 to 1, how you're gonna solve it? Can you solve it such that basically you have to find whether it's a palindrome or not? So what's the easiest way? I think easiest way is you just create a list of integer, right? Go over each of the elements, right? And put all these elements into their array list, right? So let me write here. Algo one. Brute force will be put all elements of linked list. Um, my keyboard is not working in array or list maybe, and then check for palindrome. Right. So this is the first thing you can do, and this is the easiest. And this is something you should not do, of course, in the interview because it is not the requirement actually to convert the linked list into the array list and then solve it. So, but of course you can do it, and this will be too trivial. Another thing is we can do is yeah. So here you see the very first thing you have to use some extra space, right? So in the linked list. What other you can do? You can other do is basically copy all these linked lists in another linked list. You try to create one more linked list, right? And then you try to basically reverse that linked list and check whether the elements are equal or not. So this is the another thing you can do, right? And that will also be a linear solution. So if you want me, I can quickly write how you're gonna copy paste, basically create a deep copy of the linked list. But this is not what questions ask. We have to solve it linear time and constant space. So what's the idea? So the second algo is like create a deep copy of list, linked list, I would say, right? The algo three is what we are looking for with linear and a constant space. So what's the idea? The idea is something like this. Let me show you. One, two, and one. So I mean, say the requirement for this question. Let me write it here. Requirement, I think, is you should know linked list traversal, right? So this is the first thing you should know. And then how you're gonna reverse the linked list. This is the second thing. Reverse or linked list. So this is the second thing. So if you know these two algorithms, how you're gonna do traversal and how you can reverse it, you are good. You can solve this question. So so we're gonna use this technique. So what's the idea? Idea is something like that. Let me show you. Two and one. Sorry. So if I can reverse just this part of a linked list, or maybe I can, yeah. So the first thing is I will try to find the middle of a linked list. So let's say I found this, right? One, two. And maybe somehow I can convert this linked list into, I can basically break something like this, right? Something like this. And maybe then I can reverse the linked list, the above part, right? So maybe something like two and one. And then I can simply iterate and check whether two one is same as two one or not. So I hope you get the high level idea. So for example, let's say now we have an even number of elements, one, two, and maybe one. Yeah, and one more thing is find middle of a linked list. So this is also you need to solve this question in most optimal way. So this is the three algorithm you need. So here, so my middle element will be something like this, right? And maybe I can extract this one, two as something like this, one, two, and then maybe one. Now I will reverse this one, two. So reversing will make again this one because the single node, right? And then I can check one, one matching. And then since it is the odd number of nodes, so yeah, one extra is fine. So yeah, this is the idea. So let's try solving it. Um, so what's the first step? The first step is finding the middle of a linked list. So for finding the middle of a linked list, you can use a slow or fast pointer technique. So slow pointer moves one step at a time and the fast pointer moves two step at a time. Right. So when the fast pointer is the end of a linked list, your slow is the middle of a part. So for example, let me show you how it is. So let's say this is your linked list. Right. Now our slow is also at the one and our fast will also be one. Now slow is now the very next step. Slow will go here and fast will go first next, right? So fast will go here, right? Now in the next step, my slow goes here and my fast goes here, right? Now you see the slow is the middle of a linked list because our fast has end at the end of a linked list. You see the idea? So I hope you get the idea. Let me comment this one also. So first step, finding middle of a linked list. Finding middle of linked list. So I'm gonna create a slow pointer. Gonna start and point with head, fast pointer, right? It is also going to point head, and then something like while first is not equals to no, and then first connects is not equals to no. I can say slow is equals to slow next, and um fast is equals to fast next. Right. So this is now my slow now here. Slow is my middle, right? And now what's next? So um yeah. So now we have to okay, let me write it here. Now we have something like this. Let's say one, two, and three maybe. Now my slow is here, fast is here, slow is here, fast is here. So my slow will contains the middle. So the my slow is my next slow dot next is my new head for the second linked list, right? So I can say um for something like a head two. So this is linked list head of the second part that we break equals to slow dot next. Right. So this is basically we are talking about this part. So I hope this is clear. So here, if you have an even number of array, sorry, linked list. So my slow is here, fast is here, slow is here, fast is here, and slow is here, right? Slow is my head of a second linked list. So for even, we have to make sure. Let me see. So for one, two, let's try to simulate this one. One, two, two, and one. So my slow will be at one, fast will be at one. Now slow will be two, fast will be at two, right? And then slow will be here, and fast will go to the out of this linked list. So my this flow is the head, new head, right? So I don't have to do next. Similarly, if it is a middle element, so one, two, one, so my flow will be here, right? So two, one is what um is my the next list that we need to reverse. So what need we need to do now? We need to make sure that we need to reverse this part. Okay. So before that, we need to make sure um yeah, we just now we have this. Now we're gonna reverse head 2, and we're gonna get a new head. Maybe I can say something like head 2 equals to in a reverse. So my 1 2, I need to change it to 2 1. So 2 1 is need to change as a 1 2, and right, and then maybe we can check simply. So that's the idea. So let's now reverse it. So yeah, we did this thing, middle of a linked list. Now we have to reverse. So let's write a method for reverse. So reverse and then list node head. So what's the idea? We create 3 pointers. There is a way you can also solve it using 2 pointers, but I like this one. So basically we create a previous, right? That is going to be null. And then we have a current, which is head, and next, which is head. Now, for example, we have to, let's say, reverse this list 1 2 2 1. I'm creating a pointer just before 1, that is previous. This is current, the 1 is current, and next is 2. And then we just need to change this pointer, right? So we have to do something like current, something like this. While current is not equals to null, current dot next equals to previous, and then previous equals to current. Um, Current dot next is equals to previous equals to current, and that's right. And if next is not equals to null, and then current equals to next equals to next, and then we're gonna return the previous. So if you don't know how you're gonna reverse it, just I'm changing the pointers. Maybe after solving all the 3 questions, I might come back to explain this one in more detail, but I hope you get the idea. So now our head 2 is basically contain the reversed linked list. So in this case, 1 2 2 1, we have a list that contains 1 2 1 2, right? So yeah, now now we just need to iterate and check whether all the things are matching or not. So while something like head is not equals to null, and then head 2 is not equals to null, I can simply say if head dot val is not equals to head 2 dot val, we can return false. This means it's not palindrome. Otherwise, head equals to head next, and head 2 equals to head 2 next, and then you can return true if you're not able to find anything that is bad. Yeah, this is the idea. So this part is finding middle of a linked list. This part is reversing the linked list, and then simply we are iterating both of the linked list and checking whether the values are equal or not. So let's try compiling it. See anything we are missing. Okay. Because I haven't return type here. Anything else? Oh, it should be list. No, right. Let's again. Okay, so for 1, 2 to 1, I'm getting 2. Let's see for 1, 2, just to make sure all the test cases are running. I'm getting false. That's fine. Now you see number of nodes can be in the range of 1 to 10. So if I can simply do one base case just to make sure we are not going out of bounds. So if head dot next equals to null, this means we have only single node, right? So I can return true. A single node is always going to palindrome, right? Um, yeah, and then here you see we are not taking any extra space as well. So we are just playing with the given linked list. Let's try submitting it to see if we have any issue. No, no, we are able to solve this. So yeah, so these are the things you should know. A linked list traversal, reverse a linked list, and finding middle of a linked list, and now you can solve that problem in a constant time and linear, sorry, constant space and linear time. So let's move to the next question. See, what is it? This is the question. It says, given a string S, sort it in decreasing order based on the frequency of the character. The frequency of the character is the number of time it appears in the string. Return the sorted string. If there are multiple answers, return any of them. Okay. So we have to do the sorting, but we just need to make sure that these are sorted based on frequency, right? So for example, in the tree, you see here, EE is coming 2 times. TNR can be, it can be RT, it can be TR, right? Because both of them are single appearance. Um, E must appear before RNT, therefore EETR is a valid answer, and EERT is also valid answer, right? So we just need to sort the frequency. So what's the requirement here? You should know your comparator. You should know your custom comparator. So I think in C++ also we have lambda, in Python also we have lambda kind of thing. And in JavaScript, we have that higher order methods, right? So we can use that. So you should know how you can do a custom sorting. So what's the idea? I'm gonna let's just store first the frequency of the each character. So it's I think uh it can contains uppercase and lowercase characters. So I'm gonna do something like this. Map of map of character and its frequency we're gonna store. Right. Um new hash map, and then I'm gonna iterate over each of this character and do something like map dot merge ch1 integer sum. This is same as doing something like um frequency of ch plus plus, right? So okay, now we have to sort it. So let's first convert this into a character array, maybe something like this. Char ch s dot to char array. I don't know. We can sort a string, a raw string using array dot sort because it is mutable, immutable. So I don't think we can do that. So let's convert this into a character array and then maybe do this arrays dot sort. I'm not even sure that we can do this on character based array. Um, maybe, maybe we can do um create a list of character maybe. List of character. Um, yeah, I think this will work. There may be multiple ways, but this is what I'm currently able to think. So I think this will work. Um, List of character, and then I can do maybe something like this. I can move this here, so I can basically prevent one extra iteration. And here I can do something like this. Um, List dot add ch, and then here I can do list dot sort. And what is the comparator? A comma B. basically compare integer dot compare b map dot get b map dot get a, right? So basically in the increasing order of their frequency, and then let's create a string builder for generating our answer, and then iterate over each of the character. Var ch list answer dot append ch and return answer dot to string. Yeah, I think this is it. Um, I think this could work. Let's try compile it. See any compile time error. Okay, so we are getting EETR, and this is what we are expecting. So EETR is good, even it is a EERT is also good. So let's try submitting it. Okay, we have an issue here. Hmm, I was not expecting, to be honest, a wrong submission on this one. Let's see what we are missing. So E is fine, and then I should get okay. Okay. So this is, I think I got this. Why this is bad? Hmm. Frequency. S dot length is 10 to the power 5. Yeah, this will not work, guys. So let me explain why this is breaking first, and maybe then we try to reinvent our algorithm, right? So here you see, let me zoom a bit. So it is like that's fine. Now you see L is coming two times and O is coming two times. But we have to make sure that L comes together and O comes together, and that is what I missed it. I missed it because L is coming two times, so I put the two, and then as going to the very next character, it is O, right? So here you see L and then it is O. So sorry, L in the input and then the O. So that's why now it's checking O. O, what's the frequency of O? It is also 2. Okay, we can put it O here, right? So we have to prevent that. So this will not work. So what we're gonna do? Uh, what we're gonna do? That's a good question. So maybe I need to sort it based on the characters frequency. I think that's the right approach. But I will do something like this. Maybe I will remove this one and let me remove this one also for now, and this one also. Okay, so we have now frequency. Now I'm gonna create a list of pair, maybe list new array list, and what my pair will contain, it contains a character and its frequency because I need to sort it. So I don't need this map also, actually, to be honest, right? So let's create me a class. So this is a class in Java. It's like a immutable class. So it's like it contains basically a frequency and maybe character, right? And I'm gonna iterate over. Okay, no, I need that map for frequency. Okay, my brain is not working. I can say map new. I'm gonna iterate over my character to char array, right? And then map dot merge ch1, use the sum function. And then we're gonna iterate over our entry of a map. Oops, entry set, get the key. So key will be character, right? So entry dot get key and a value. Entry dot get a value, and then I can simply put it into my the list. So list dot add new pair frequency along with its character. Right. So this is We are creating, you can say, hybrid link, basically to make sure that our number characters are coming together, which have the same frequency. Right. So idea is again very similar to the thing that we were doing in earlier, but yeah, I just missed that. So yeah, now we have this list that contains characters and a frequency. Now I'm gonna sort this list based on what? Based on something like this. Um, integer dot compare b dot frequency and a dot frequency. So this is basically sorting each character like this. Now I'm gonna iterate over my list, right? And I can extract the character. So character will be L dot ch, right? And its frequency will be L dot f. And then while f minus minus is greater than 0, append this character in our answer. Append in answer and return it as it is. So I need to move this thing here. So yeah, this way we will prevent this thing to happen, right? So now again we are sorting, but let me show you how this is working now. Okay, let me first try compiling it and then I will explain. To see any error. So EERT is getting. Let me try for this input also to make sure. Okay, so EE and then LL, then OO and CDT. Okay, it's good. Let's try submitting it. Okay, we are able to submit. So let me explain why it is what we were doing earlier and what we are doing now. So let me copy this in one example and I can show you here. So initially now we were just sorting it based on frequency, but we are not maintaining the order. But now what we are doing, we are creating a list that is contains something like this. C is coming three times, or something like this. C is coming three times, and three is coming for A also, right? And maybe let's say we have some other characters also, maybe B, and I can do something like this. B is coming one time, and we are sorting to make sure that highest frequency number comes first. So three, then two, then one, right? Yeah, three, three, one. This is correct order. That sorting will take care of it. Then we're gonna iterate over each of these elements. So C needs to be put in my answer three times, and it has the highest number of frequency. So this is what we are doing here. So put 3C, so something like C, C, C. Then we need to put 3A. Okay, put 3A. Then we need to put 1B. So put 1B. So I hope you understand this one. Yeah, for this one you should know your custom comparator, and that's it. And you should know how you're gonna create a frequency of any string, a characters, or an array. Right. So let's move to the next question, third question. This is our last question. Okay, I think this is some weird question, guys. Oh, we have to flatten. Okay, let's see. So we have a doubly linked list which contains node and have a next pointer and a previous pointer and an additional child pointer. Now this child pointer may or may not point to a separate doubly linked list, also containing these special nodes. These child lists may have one or more children of their own, and so on, to produce a multi-level data structures as shown in the example below. Okay, so given a head of a first level of a list, flatten the list so that all the nodes appear in the single level linked list. Okay, let current be a node with a child node. The node in the child list should appear after the current and before the current dot next in the flattened list. Return the head of a flattened list. The node is the list must have all of their child pointers set to null. Okay, flattened list node in list must have now all the child pointers set to null. Okay, okay. I think I understood the question. Let me show you. Okay, so you see we have this doubly linked list, right? So one is pointing to two, two is previous is one, 2 next is 3, 3 previous is 2, and so on. Now you see here we have now new ordering here from 3. Of course, you can go to the 7, but 3 dot child dot next is something is there, right? So and so yeah, we need to go inside of this also. So we go to the 7, then we go to the 8, right? Now for this 8, we have one more node inside of this. So go inside of it and get the node, right? And then come back and then go to the next and then come back and go to the next. So it's answer like 1, 2, 3, then 7, 8, 11, 12, then 9, 10, and then 4, 5, 6. So this is what we need to return. Okay, this is going to be interesting. So if I see the constraint here, it says 10 to the power 5, so you have to solve in a linear. Okay, no, it's like 1000 nodes, right? The node will not exceed 1000, so you can solve like n square based solution will be accepted for this. Okay, so in such kind of problem where we do this nesting thing and then come back and do the nesting, then come back, it makes me feel like we can solve maybe um what we say recursion. We can use that, but let's first try to solve it without recursion because I'm not sure about it. So what will be the idea? The idea is I will start with a one, right? Okay, this is fine. Then go to the two. This is fine. Then go to the 3. Now here, since 3 dot child is there, hmm, we need to add that element first and then go to the next, maybe go to the next and go to the next. Because we have to come back also. Okay. How we gonna do this? Can I do a simple iteration that will work? But how will I know that nested things are done their work? So that's where I think you should use recursion for this multi-level based parsing. But I'm still not sure how we're gonna do that. Maybe I can use stack and try to simulate it kind of like recursion, but a stack. So for example, I will push 1, I will push 2, I will push 3, right? And then we have a child node. So I will push that first. Then 8, I will push this one and then this one and then push goes to the test, and we need to make sure the child at next is equals to null. Okay. This is interesting. I'm not sure about it, but let's see. What if I try to write a recursive method for this one? What we will I need? Maybe I need something like this. Um, so we have to return maybe node my magic method I call, and it gonna have a head. What things I need to define? I will say magic um head dot next, right? Try to solve my child first. No. First we have to solve magic um head dot child, right? If we have a child that is not null, and after solving all the child, go to the next, right? So this will done that. This will do that. But before that, and then what I need to do? I need to do is I have to process myself also. So um, I don't think then we have to do anything then. I just need to append that result, maybe reverse it. Okay, I'm not sure. Like 1, 2, and then I will move to 3. Now 3 has a child. I will move to the child. Mm, maybe I can create a global variable like list node dummy, right? New list node, something like this, and then list node tail that is going to point my dummy. So maybe tail dot next is this. Then I will move to the next element. Then move to the next element. Uh, 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 yeah, I think this should work, but I'm still not sure about it. So for example, here, let's take the simpler one. So I'm at one, right? So my list dot node will contain one. Tail dot next equals to one, and tail is equals to tail next. And since it is a child, I will go inside of my child, and then I will do that, and I will come back. Whenever I return, I need to make sure that my head dot child equals to null. So maybe something like this. Head dot child equals to null after returning. Okay, okay. And then do we have next? And if you have a next, I'm called head dot next. So yeah, this is what I'm able to think, guys. Let's see. Let's see. Let's try to write some code maybe. Then maybe we are able to understand it more. I'm not very comfortable with recursion at least, but yeah, think I have solved enough question to solve this one. Let's see. Let's see. Um, so as we discussed, I'm gonna create some dummy node first. List node. I will call it dummy new list node. It is not going to point anything. And list node, or maybe we can define this here. Dummy and tail, and something like this. Dummy equals to new list node, and then tail equals to dummy, right? Nothing fancy. And we're gonna return dummy dot next. And before that, we have to call my, let's say, magic. I will call my method magic. I don't know why, just call it. You can call it whatever, right? And my formatting is bad. It just hurts my eyes. But let's go with it first. I mean, and let's write this recursive method, our magic. Uh, so we need to process this one. So what needs to be done? First thing first, I go to the first node. I will add it in my list. So I can set tail dot next uh, equals to head and tail equals to tail next. So this is the thing we have to do. So that if head dot child is not equals to null, this means we have to go inside of it, right, to flatten it. So I will call magic head dot child dot no, head dot child only. Head dot child. Head dot child is it? What's the structure of this node? Yeah, I think head dot child will make sure we are moving to this node. That's fine. And after doing this, head dot child, we also need to make sure that head dot child equals to null now. So this is what question has asked, right? So here somewhere was there. Yeah, let's leave it for now because I'm not confident on my algorithm right now. Now this will help me process all the nodes inside of it. And then whenever we are able to proceed, we can say if head dot next is not equals to null, please solve my magic method for head dot next all. Now what will be the base case? This is interesting. So if head equals to null, we can simply return it. Okay, let me first format this. I don't like this. Control X. remove. I like formatting. I mean, otherwise it just makes my code look so bad, and I'm not able to focus. But yeah, so this is it. I'm not sure because this is what question I have asked, and this is what my magic method is doing. I'm not sure. So for example, we are at head. So very first node comes, right? That is one, and we're gonna say tail dot next. So let's say we have this tail. So tail dot next is equals to one. This is fine. And then if head dot child is not equals to null, yes, it is not equals to null. So go inside of this method. So we go inside of it, and I will append three now, right? And now we do okay. We need to do head dot next also. After doing this, we also need to do no. So head dot child, yeah, this is fine. So we go to the three. Now again for this method we append this three, then check head dot child is not equals to null, but here it is null, so we are not going inside of this one. Is head dot next not equals to null? No, it is null. So it is null, so we're gonna return back, right? And then we're gonna do like one dot next. We return, and head dot next is not equals to null. We do head dot next. Yeah, I think this is it. Let's try compiling it. See if we have any compile time error or not. Okay, we have. So it says return dummy dot next. Where? Incompatible type node. List node cannot be converted to a node. Okay. I think I missed it. It just says node. Control Z. D. Oops. Control Z. I have to call it node, not list node. Let me try again. Okay, we are getting what we say null stack overflow because it is going infinite at here. If head dot next is not equals to null, move to the next node. Why we are getting this 22? Um, Maybe let's try for simpler one. This one, just to understand. Otherwise, yeah, at least we can debug. For this one, I think I should use my ID. I'm not sure because I need to debug so many things. Yeah, but now let's see why we are not. It is not going to here. Head is equals to null. It should return. Mm, let's see. So we go to the first node. We do our mapping. This is fine. Then if head dot child is not equals to null, you go inside of the child, and I think I have to do something like this here. Make head dot child is equals to null and return it. And then okay, and then head dot next is not equals to null. Okay, I think I can do something like just do this. Head dot next not null check. We don't need to do that null check. But for child we need to do that. Let me try again. Okay, so we are getting 1, 2, and which is wrong because we are not going inside of this tree. Why? Let me first previous pointer. Do I note this previous stuff? Previous, why they have given this previous pointer? Additional a child pointer. This child pointer may or may not point to a separate doubly linked list, also containing these special nodes. The list may have one or more children of their own and so on to produce a multi-level data structure. Given all head of the first level of the list, flatten the list. so that all the nodes appear in a single linked list, doubly linked list. Let current be a node. The child list, the node in the child list should appear after current and before current dot next. This child structure flatten the list, single linked list to be node child and list appear after the before linked list. The flattened node in the list must have all of the child pointers set to null. Hmm. So why this is not working? So we are head equals to null. We are returning. So tail dot next is equals to head, and then tail is equals to tail next. Fine. Then do I need this? I can just say something like this. If we have a child, go inside of that child and solve it. Let me try again. Okay, because head dot child, we are going inside of this child. For test cases 1, 2, and null 3. Um, head. This is my head, right? Dummy node head. Mm, 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 mm. Yeah, I think this is fine. Tail dot next equals to head. Tail is equals to tail next. Magic head dot child. Hmm. So head dot child will go. I think I should ideally I should get this one. I don't know why it's not working. Why it's not working? Okay, let me now first see the structure of this node. How was so? Let me copy it and maybe revert it default to see what is the structure. So this is the structure, right? So we have val, we have previous, we have next. I don't know why they have given this previous. Mm, and then we have this node child, which gonna help us whether we have to go inside of it or not. Okay. Uh, mm, let me what's wrong? Okay, so for one, I take this node and do something like take it and append it in my tail, and I will call magic head dot child. So head dot child. Do we have to say like head dot child dot next? Not sure. Head dot child. Given the head of a linked list, flatten. Okay, here. Node have a next pointer, a previous pointer, and a child pointer. And this child pointer may or may not point to a separate doubly linked list, also containing these special nodes. So just for testing purposes, now let me see what's inside of this. Um, Maybe something like system dot out dot println head dot child dot val. What you got, bro? Okay, I know it will go for overflow, but at least I can see the input. No, 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 no. Yeah, I think I know why this is failing because you see, from one we are going to the child, right? And from child, again we are going now, then we return, and then again we are going child and child and child and child. So that's why this is happening. So maybe I can mark it visited or something. Maybe something like if head dot child is not equals to null, then only call this thing. Uh, right? And do something like head dot child equals null because we have already processed all of its elements. And let's run it again. Okay, now child dot val cannot read value because child is null. But why null? This is here, right? One is pointing to three. What am I misreading? Am I misreading the question or what? Do we have to do like child dot val? Uh, head dot child dot next dot val? I'm not sure. Let's see. No, because child read next because child is null. Why my child is null? I'm using this test case. 1, 2, null 3. Let me print here. Print ln head dot val and maybe use example test case and run. Yeah, for this one, um, so this is the first example. 1, 2, 3, null, 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 11, 12, and 1, 2, 3, null, null, and then we have an empty list. Okay, so 1, 2, 3. Where is the output? Okay, let me remove this one and this one also, and let's run it. Yeah, so 1, 2, 3. You see here 1, 2, 3, and then I'm doing 4, 5, 6, but I'm not going inside of it because according to my thinking, it is getting null. But why it is getting null? Head dot child must not be null. Oh, because of this. We have to first call it and then do the null thing. Right. So let me run it again. Now it is going to the infinite loop. But yeah, at least we are able to get something. But I know why this is happening because we are going here checking not null. Call this head dot child. And then we are going again, we are coming back and doing head dot child. And again coming back, head dot child. Hmm, how we can do that? No. So one push into the maybe stack, one, then two, then three. And do we have a child? Yes, we're gonna push it. Seven, eight. Do we have a child? Yes, we're gonna push it. 11, 12. And we are not having next. So I'm gonna 12 and 11. Okay. Maybe I should use the stack to solve this. So like one push it, two push it, three push it. Now we have a child. We go 7, then 8, and then 11, then 12. And then I need to return, but why this is not working? Let me rewrite this. Okay. So, mm, if you have a child, head dot child is not equal to null, please solve that first, right? So head dot. And after solving that, mm, how we can mark this to be kind of like with data, something like that. The node in the list must have all of their child pointers set to null. How I can set null now? Because this is what I'm doing. Go inside of a child, and what will I will do with myself? I will say tail dot next equals to head and tail equals to tail next. This is what I will do. So first, go inside of the child and do your magic. And after doing all those things, I will add myself into the head of a linked list. Mm, like if head equals to null, we're gonna return. If head the so we go here one head dot child equals to null, so we are not going to call. We simply say tail dot next is equal to head. Then go to the rest and go here, do that, and move to the next pointer, right? So magic head dot next. If head dot child is not equal to null, head dot child, then how can I make sure we are not going again inside of this for child node? If I mark it here, this that will be bad, right? So after doing the all things, when I return, I can make it like head dot child equals to null. So for example, here at 1, head dot child is not equal to 1, so I go inside of it. Okay, so I have to do this verb only. So I will do that, and then head dot child is not equal to null. I will call this method, and whenever this method returns, I will call my head dot child equals to null. Head dot child. Not sure about it. But we have time, guys, at least. Magic head dot next. Okay. So maybe so if head dot child, go and solve yourself, and then solve head dot next. If it is not null, if it is a null, then solve head dot next. Is this what you want? No. Do I need to keep track of visited or something? I don't think so. We need that. Okay. Magic head, dummy next, and that is fine. We created a node, dummy, and tail. Tail dot next is same as dummy dot next. That's fine. Mm. Why? This is not working. Okay. We have 1 hour left. Let's see. Use example test cases. Let's try to easier one first. Run the code. Yeah. Okay. Mm. Okay, so for magic, head equals to null. I'm returning. Do you have anything else for this? Mm, no, I think this is fine. Tail dot next is equal to head, right? And then tail is equal to tail dot next. This is fine. Now, if head dot child is not equal to null, so here head dot child is not equal to null. One child is pointing to the tree. So we going inside of this. Now again we are saying head is equal to null. No, tail dot next is equal to head. Fine. One is three. And now this is my new tail. And I will call what? I will call magic head dot next. Okay, we have to do something like head dot child dot next, no? Head dot child dot next. And here we need to make sure we are doing it here after doing all those magic. Right. So if head dot child is not equal to null, so here one child is three. I'm calling head dot child, and then no, why I need this head dot child? I will call it the three. And I need to call head dot next. This is what I have written earlier also. Okay, do I have to use my pen and paper? I think so. Let's again try to understand why this is not working. So one is pointing to the tree. So we go to the fourth node, we take one. So something like my tail is pointing to one. Then head dot child is not equal to null. That's fine, not null. So we call magic head dot child. Go inside of this node and try to solve it. So my magic method has this head three. I'm going here and doing the combination, basically linking. Three is also here. Now, if head dot child is not equal to null, oh, it is equal to null. If it is equal to null, then I'm saying magic head dot next. So this one next. So this one next is null. So we're gonna simply return and we're gonna return here and then we're gonna call magic head dot next. So this is my current head and head dot and next was this node. So we are going to do two. Yeah, this is fine. Why this is not working? Let me run again. Back over to error, but why? Why? We are doing head equals to null. We are returning. Mm, this means that head dot child is not equals to null. Now, what about this one? If head dot child is not equals to null, go inside of it, right? And then again do next, 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 and again do next, next, next. But I'm not understanding why this is breaking. So like here, multi-level English example one, two, then we go to the three, right? So at three, we have do this linking, and head dot child is not equals to null. Yes, so I'm gonna go like head dot child. I'm going inside of the seven. Okay. Now seven dot child is null. So I'm going seven dot next, which is eight, and then I'm going eight dot child is not null. I'm going 11. Then I'm going 12, right? And it is next is null. So I'm returning, 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 and then going again here head dot next, and then again head dot next. I think it should work. I'm doing very silly mistake, that's for sure, and I'm not able to identify it. Okay, according to my logic, I think things should work smoothly. But why this is not working? Tail dot next equals to step. Tail equals to tail. Now I have only one choice. One choice is that can debug everything. Print ln head dot val where we are talking. I'm not even able to see the, I think, my debug statement also. You see, 133, we are stuck at 3 here. Head dot child, head dot child, head dot child. You see the issue here? So from 1, we are going to the 3. And in the next call, again it is a 3, again it is a 3. But I am passing the head dot child now in my next method. What am missing? You see here, 1 3 3 3, we are stuck at 3, and I'm not sure why, because here head dot child is not equal to null. That's fine. So we are calling magic on head dot child, which is 3. Right now we are pointer, my head pointer is here. Is it null? No. I'm printing it value and then doing tail dot next is equals to head and tail is equals to tail dot next, and again I'm doing head dot child is not equals to null. No, its child is equals to null. So we are not going inside of it. We are coming here. Head dot next. Head dot next is null. So we are coming here and then we are returning. Then we returning. Then we returning here. And then again maybe one, but one dot next should run. Okay. What the 1 3? This is fine. This is also fine. This is also fine. But there's something I'm not able to think. What is it? What is it? Head dot next. We have a multi-level linked list. Mm, 1 2 3. That's fine. I mean, If head equals to null, let's try to go one more time. Head equals to null. This is it. This is fine. Then tail dot next head. Head dot. Then node dot next. This is also fine. Maybe do I have to maintain the change the previous link also? I'm not sure. I think this is correct till here. Maybe because no, we need to save this pointer there somewhere. So for example, you see guys, from one we are going to the three, but we are not saving this two. We might need to go to the two also. So can we do something like this? Node next pointer is like head dot next, right? So this is just from one. We are because we are going inside of this three. We need to keep track of this two. Like later we have to go on two. Wait. Um. And then if head dot child is not equals to null, we are doing this, and we also need to make let's say head dot child equals to null. This is what question I have asked. And magic on instead of head dot next, let's call it next. So I'm just keeping track of my reference and yeah, similar logic that we were discussing. Let's try again. See. Okay. So 132 we are getting. Okay, just I think I messed up this reference when I was doing head dot next. So here, why this is not working? So if I do something like here, like this, head dot next. Okay, so I think it is pointing to the initial head, then it will throw me that Stack Overflow error because now I'm talking about different head, this head, right? Okay, this is the issue, I think. I see it is going infinite loop. Let's take this example again. See, run it. Yeah, we are getting 1, 2, 3, 7, 8, 11, 12, 9, 10, 4, 5, 6. Yeah, we are getting fine. Pretty happy actually. We are pretty close. I think I just messed up this condition. I have to take the reference initially and then do my sum work and then call my that reference instead of just using the old reference. Hmm. And since it's a doubly linked list, I'm not maintaining my previous, but let's see. Let's try submitting it and see. Do I need to? I'm not sure. Okay. The linked list is not a valid doubly linked list. So we have to return a doubly linked list. Maybe here just very simple, right? Tail. Head dot previous equals to tail. I think that's it. And this is it. Head dot previous tail dot next is equals to head and head dot. Yeah, this is fine. Let's try again. To see any compile time error? No. Uh, why? I have not made the double link list. Let's try submitting it. No, I'm getting this again. What it says, the linked list is not a valid linked list. Okay, what I'm missing now? So I'm creating a new node. I'm creating a tail. I'm calling my method. I'm calling dummy dot next. If head equals to null, tail dot next is equals to head. Head dot previous equals to tail, and tail equals to head. Oh, sorry. Right. Tail dot next equals to head. and head dot previous equals to this, and tail equals to head. But this is the same thing. No? Let's try again. It's not a valid linked list. What what I'm missing? Hmm, This is not valid linked list. Why is this not a valid linked list? Yeah. Dummy. Okay, so here maybe dummy dot next dot previous equals to null. And yeah, this is it. I think dummy dot next dot previous. Yes, that's correct. Oh, here I okay. This was very weird question. Yeah, I think that's it. So we also need to make sure our dummy dot next dot previous, basically head dot previous is also null because we are creating a new node from the scratch. So let's try submitting it. Okay, we are getting null pointer exception for what? At line number 7 for empty. Hmm. Because our head was null. So if head equals to null, return head. Let's try again. Yeah. Okay. So this was, I mean, it was not tough if I haven't messed up this condition. And now this will, I will remember for my whole life, right? So this is the benefit of, I mean, problem solving. It makes you stuck on something and then you learn something that you're not gonna forget, right? So yeah, that's it for today's video, guys. So question number one was, I think, yeah, bunch of learning you can do from question number one, traversal, reversal, and middle. Question number two was, I think, easy, just a sorting. And question number three was flatten a linked list. This was indeed a very good problem, I would say. I stuck on, I think this is a medium level problem or hard level problem. I'm not sure. I need to check. But yeah, I hope you like it. And thank you so much for watching this video. I think it has been very long. I'm sorry for that. So yeah, I'm stopping the recording. Thank you so much.